All right, so today I've been asked to present about the WeatheX app, which is a community severe weather reporting project in Australia. Currently, it's run by myself and Dean Scabosa at the Bureau of Meteorology, but it has its roots originally within our university sector. So starting off, I'll introduce you to the motivation for WeatheX itself. So we know community severe weather reports capture localized events that are either difficult or effectively impossible to measure with our standard instrumentation. An example of this is hail size. So, however, this data is widely used in science, operational warnings for situational awareness, and commercial applications too, in particular risk modelling. So within Australia, we've had a fairly long-term reporting program called the Storm Spotters program that began in around 1989. And the graph below shows the yearly count of hail reports from this program as reported in our Severe Storms archive. So you can see around the early 90s when the program kicks off, where we saw around 100 reports, 100 to 200 reports per year. This is just for the hazard of hail. And lately we've seen the number of reports through this platform started to decline. And this is a big motivator for WeatheX. From this drop-in reports, we've been motivated to explore new platforms and new ways to engage the community for severe weather reporting. So I'm going to hand over to Dean Scabosa now, who's going to talk about the operational aspect.
Cool, thank you, Josh. So as Josh alluded to there, we have seen that reduction in direct reporting to the Bureau of Meteorology. And this can be attributed to a number of things, but I think the two main ones I'd like to draw your attention to is one, that the current Storm Spotters program does not utilize a user-friendly approach to submitting these reports. They are still largely manual, requiring the downloading and printing off of a manual form. So there's no mobile app or public web page for reporting. The second one is the dramatic increase in social media, storm chaser and weather personality pages, groups and so forth across the multiple social media platforms. And one thing we've seen just anecdotally is that people seem to be more likely to post their photos and reports to one or more of their favorite weather-related groups and pages. And in doing so, it makes it increasingly difficult for our operational meteorologists to find these reports. It often requires quite a tedious, time-consuming process of scrolling through numerous comments, posts, and so forth to try to find evidence of severe weather. And it seems also that people are less likely to post their photos across multiple groups, which makes it even more difficult to try to pinpoint which groups we should focus on. And lately, particularly the last few years, we've seen that this issue has been exacerbated by some of these groups and pages forming cooperatives and hiding images and reports behind paywalls to attract media licensing revenue. And one example of that is Severe Weather Australia. Thanks, Josh.
So we can see here there are a number of factors which are limiting the current approach for collecting reports. So we saw this as an opportunity motivated by new technology and of course the increasing risk and exposure to severe thunderstorms we're seeing here in Australia. So a proposal was submitted to the Australian Research Council Centre of Excellence for Climate Extremes. So this is a multi-university funded approach. And the WeatheX app was awarded in early 2018. So this app is designed around delivering a modern platform for these public reporting while drawing on lessons from successful US and European reporting apps. So now we'll go into this in a little bit more detail. So we designed the app WeatheX around 5 central pillars. We wanted it to be accessible. So this means in the mobile space, cross-platform, and of course free. We wanted to remain relatively focused during its early stages, so we only implemented 4 key weather types, which I'll touch on later. We wanted the interface to be attractive, minimal, So this encourages the users they don't need any special training or education to use it, and it's also quite quick and seamless. And also we wanted to protect the user's privacy. So we focused on anonymous reporting and also the security of that data. So this is just a quick video demonstrating the WeatheX app. I'll go through these features in more detail later. So you can see the severity selection, photo selection, a comments page. So these are the basic features of the app. You can see a report was submitted then in only about 15 seconds, and it only took 4 clicks. So it's really designed around this minimal approach to collecting the most valuable information. So following version 1 release, we've recently reviewed the WeatheX app as part of a workshop funded with both the university sector and potential stakeholders in March 2019. So this workshop established a priority list for new features and improved features for the current version which is available. And some of these include improved social media integration so that reporters can post their own reports to social media, an alerting system for nearby reports, improved safety messaging, and also improving the API so that stakeholders and the public can access data under the privacy controls. So some examples of the new social media sharing feature is shown on the top right and the reporting feature on the bottom right. So over the past 2 years, WeatheX has collected more than 2,500 reports. And since the release of the second version, version 1.1, we've recorded more than 1,100 reports in the last 3 months. And 10% of those approximately contain photos as well, because photos are not mandatory. We see about 50% of these reports were hail, slightly lower percentage were wind reports, and also in the first version, we had flood and tornado reports. The tornado has subsequently been removed and replaced with rain reports. Most recently, we've had a very significant hailstorm event on the 31st of October 2020 through the southwest suburbs of Brisbane. You can see the plot on the right showing the Brisbane area and the reports from WeatheX, where the different colours indicate different hazards. So for this event, it really showed the potential of WeatheX, where we received more than 250 reports and more than 130 of those were hail, allowing us not just to look at individual point observations, but to begin to develop a spatial map of hail size across this event. The ultimate challenge, of course, is to keep people engaged. And this is a chart showing the first 7 months of WeatheX of the number of installed active users on the Android devices. And we can see following initial bump ups, following which occurred during media releases, we can quickly see that without regular engagement, we see the number of users continuing to decline over time. So this is something which we've approached in version 1.1 by including features such as the social media integration and also the alerting so that people get alerts when there are nearby reports. So now I'll just go through how WeatheX actually works. So as I mentioned, it is a free app in the Google Play and iOS stores covering both platforms. We try to support as many operating systems as possible. There is no user registration. We wanted to keep reporting entirely anonymous and only requires location, camera, and storage permissions. Upon opening the app, the first thing you see is the last 24 hours of reports within your region. So the size of the icons is also scaled by their age, with smaller icons for older reports. From this screen, the user is able to access settings, share the map, or submit a new report using the plus button down the bottom. So in the current version, when you want to submit a new report, you have 4 options. We've kept it minimal again. So we've focused on rain, hail, wind, and flooding. For hail, we have quite a novel horizontal slider that lets the user select the hail size against reference objects, starting from our local currency all the way up to tennis balls. For wind, we actually use impact to measure wind strength. So we have 4 options which were developed in consideration for the F scaling, so that we can have an approximate idea of what the wind speeds were based on very easy to assess items such as vegetation and general impact to structures. We have flooding, and again, this is kept relatively simple. In particular, we wanted to focus on reference objects such as roads and ground floors of houses. And rain. And the rain feature is actually there more to encourage regular reporting and use, because obviously rain is the most frequent of those 4 hazards which people may experience. So we've seen this has been actually a big success where we get lots of reports of rain, and they also actually act as a null case for hail occurrence. So we can start to use them during hailstorms to actually map where we didn't see hail, which is quite nice for a change. So after submitting the report severity, we're able to add a photo if the user wishes, and following that, add comments if the user wishes. And after submission, they're offered the option to share to their social media account, which can be any social media account. And finally, we have a series of settings integrated to adjust the public access to weather reports and the photos which are collected. So a user can control these permissions. And through the API, the images and reports which the API provides reflects these permissions on a user basis. Handing back over to Dina.
Thanks, Josh. So an example there that Josh had shown previously was the Brisbane, Queensland Halloween hailstorm. And from that, we received 144 WeatheX hail reports in the 15 to 15 UTC standard day that we tend to use in Australia. And on the bottom left, you can see the operational viewer depiction of that event, and Josh had showed those numerous icons over the Brisbane CBD region. But on the top right, I think I'd like to draw your attention to this. This is what we saw earlier, was the Severe Local Storms database showing hail reports. Now, on this one day, we received 144 hail reports. Now, that in the Severe Storm database, we've only seen 6 years, so that's complete years with more than 144 hail reports. And I think this is a really nice demonstration of how successful a reporting app like this can be in high impact weather events such as this. Next slide, please, Josh. Okay, so I'm just going to take us on a little bit of a journey now about why observations and reports are so important to us in operations. So I like using the philosophical thought experiment that many of you have heard. If a tree falls in a forest and no one is around to hear it, does it make a sound? But if we apply that to operational meteorology, if a tornado occurs in a field and no one is around to see it, did it actually happen? So this is directly related to our ability to warn for severe phenomena, particularly severe thunderstorms, with the amount of and the weighting of evidence that supports the potential for that severe phenomena to occur, in conjunction with all the weighting of radar, satellite, environmental assessment, mesoanalysis fields, etc. But observations and reports are always given the heaviest weighting and act as truth. So in other words, we could have a mounting of evidence, right? But unless we get a true report and a reliable observation, we're never really quite sure that the event actually occurred, unless obviously retrospectively due to damage that was discovered later. So reduced reporting of severe phenomena therefore directly impacts our ability to warn for and communicate the risk to the community and our customers and stakeholders. And this represents an enterprise risk for any weather agency. Next slide, Josh. So it's also, the reporting is further complicated by population sparsity, which is an issue that we face in Australia. And therefore, it becomes even more crucial that we receive reports and observations if anybody does actually see it. So our philosophical argument then becomes, if a tornado occurs in a field and the farmer witnessed it but did not report it, did it happen? And again, the answer is no. So ideally, we'll have a reporting structure where a tornado occurs, there's an eyewitness, and then they report it and it feeds directly into our organisation. Unfortunately, our current reporting structure is complicated. One where we have an eyewitness, that eyewitness does nothing, or they report it to their favorite storm chaser or storm weather enthusiast page, from which they do nothing. We don't know about it. It's locked behind a paywall, or we may actually see it from operational meteorologists scrolling through these pages while on shift. Ideally, as represented on the bottom line there, though, the witness actually does report it, and then we receive that directly within the Bureau to inform our forecast and warning process. Next slide, please, Josh. So hopefully you can see there that observations and reports are particularly important, but they're very important for our verification. Now, I like to use this approach of 5 considerations that we need to make an informed forecast and even warning for a weather hazard. So if we have increased observations, we improve our situational awareness. What is actually happening? What is the potential? It improves our forecast and our warnings because we're more aware of what could happen and what is happening. It also improves our certainty in the forecast. So we could, via verification, we can say, well, how well does NWP handle situations like this? Or how well do we typically handle warnings or warn for and forecast for situations such as this, which feeds into reliability of the forecast, which aids us in communicating to our customers how confident we are in our forecast. And finally, that provides context to the situation. So this is moving to saying severe thunderstorms may occur to, but what are these severe thunderstorms going to do in the context of our customers? Next slide, please, Josh. So just to conceptualize here in this graphic here, so if we have these additional observations and reports available in operations, we can use those to confirm any severe phenomena, which prompts us to modify our conceptual model of the atmosphere and our environmental assessment, which improves verification of our forecast and warning services and promotes a culture of continuous improvement. And these combined will lead to increased accuracy, precision, and lead time in our forecasts and warnings. And in that concept graphic there, we can see those WeatheX reports in the trail or swath of a thunderstorm, which then directly informs our thunderstorm warning. And in a future probabilistic service, and as we move to impact-based forecast and warning services, we can communicate the increased risk in the probability space of individual hazards associated with severe thunderstorms in this case. Thanks, Josh.
Okay, so the future of WeatheX. We're currently focusing on the transition from a university-owned project, because it's currently with the Centre of Excellence for Climate Extremes, to a service operated by the Bureau of Meteorology. And as you can imagine, this is a fairly lengthy process with lots of considerations. On the science side, however, we're still exploring the automated and manual QC processes, which would be required, particularly what's required if we start receiving hundreds of reports per day. And also exploring new ways of rewarding regular reporters, because we want to encourage people to keep using the app. And whatever we can do to achieve that is, of course, important to its success. We're also quite keen to add new hazards, such as snowfall, bushfire plumes, and storm surge. So these are hazards which are very easy to photograph and also for the public to report on. And also we're looking at more specific impact reporting. So we have some impact-based reporting for wind, but we're also quite interested looking at impact-based reporting for other hazards as well. And of course, what we want to do with the WeatheX reports is continue our long-term severe storms archive. So we're looking at the synthesis with the existing data set here. Thanks everyone. And